Hello everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 7C. Myself, Vidhi Rahangdale, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, that is ICICT 2026 in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held day before yesterday in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write to me in chat box. Just before we start the session, I would like to introduce you all to the chair for this session. We have Dr. Peppa Petrova with us as our first chair member. Dr. Peppa Petrova is an assistant professor at the University of Library Studies and Information Technologies located in Bulgaria. Her scientific interests include data analytics, data storage, data visualization, business intelligence, artificial intelligence, machine learning, and information systems. She also brings over 10 years of experience in real world business projects, reflecting a strong blend of academic research and practical industry engagement. Welcome to the session, ma'am. Would you like to address the participants?
Hello, can you hear me? Vidhi, thank you so much for the introduction. I would like just to share a few words with you. It is a great honor for me to welcome you to our session today. We're so lucky to have you all today. We have presenters from Australia, Finland, India, Kenya, Vietnam, and with variety of topics. So let's get started. It will be a really interesting session. Thank you so much. We can start.
I would like to introduce the second member of the session chair. As the second member of the session chair, we have Dr. Rachna Sable. Dr. Rachna Sable is working as an assistant professor and HOD in GH Raisoni College of Engineering and Management, Pune, Maharashtra. She has total 17 years of experience. Her area of expertise include machine learning, deep learning, natural language processing, computer vision, and statistical analysis. Welcome to the session, ma'am. Would you like to address the participants?
Thank you, Vidhi, for such a nice introduction. I welcome all the participants and hope all the sessions will be knowledgeable and will provide wonderful knowledge to us also. Thank you for the honor. Vidhi, am I audible?
Yes, ma'am. We
Yeah.
would now like to invite Min Tin Nguyen to present his paper titled An Interactive Learning and Research Platform for Real-Time Adaptive Feedback Cancellation Systems.
Hello, I am Ling Chen. I'm the corresponding author of the paper. Today, Mr. Minh Tian cannot attend the conference, so I will represent the paper. So let I share the. So here's the slide. Can you see the slide?
Yes, it is
Yes,
great.
we can see this.
Okay. So I am Linh Trần. Ladies and gentlemen, on behalf of the team, I would like to represent the paper, an interactive learning and research platform for real-time adaptive feedback cancellation system. So the problem of the hearing aids and public address system is acoustic feedback. You can see in the block diagram here is an hearing aid system. You can see that here is a loudspeaker and here is a microphone. And the acoustic feedback is the signal from loudspeaker is coupled to microphone. So as a microphone here, we have not only the incoming signal U of N, but also the feedback signal V of N. This signal will be delayed and amplified through the forward path K of Q here before going back to the loudspeaker, making the system is a closed loop system. After several loops like this, the feedback signal becomes strong and it makes the system become unstable. And in some cases, howling may occur. The feedback problem limits the maximum stable gain of the system and also degrades the sound quality. In the last 60 years, there are many adaptive feedback cancellation methods have been proposed. For example, one adaptive filter is used to estimate the feedback path, and then the feedback signal is subtracted from the microphone. So the error signal here contains only the incoming signal. If the adaptive feedback here is work perfectly, that means you can estimate correctly the feedback path. However, due to the correlation between the loudspeaker and the incoming signal, the estimation of the feedback path here has a bias. To reduce this bias, a common method is to use pre-filter to pre-whiten the input of the adaptive filter. So we can pre-whiten the loudspeaker signal and pre-whiten the microphone signal. The input of the adaptive filter here is a pre-whiten loudspeaker signal, and you can compute the pre-whiten error signal here, and it is to control the adaptive the adaptive filter. The estimation of the adaptive filter here can be copied to the feedback cancellation path here. So by this way, we can reduce the correlation between the loudspeaker and the incoming signal, and we can improve the conversion of the system. However, the most adaptive feedback cancellation research is only based on the offline MATLAB simulation, and the algorithm is evaluated separately, and there is no unified real-time platform for consistent comparison live performance monitoring and interactive experimentation. To bridge this gap, our contribution is to introduce a fully modular end-to-end real-time AFC platform built in MATLAB Simulink. In this platform, we provide, you can see the platform that we build in the Simulink here. In this platform here, you can see we have the loudspeaker here and microphone here. And here is the digital filter represent the feedback part. We have the input signal source, the block here that allow to select the input signal. For example, you can select the speak or music signal. And we also have scope to monitor the waveform of the input signal. Here we have another digital filter that denotes the feedback cancellation part. The main block of this platform is the adaptive filter block here, where we integrate a lot of adaptive feedback algorithm into it. For example, the normalized limit square algorithm, the A5 projection algorithm, and some improved proportionate algorithm like improved proportionate normalized limit square and improved proportionate A5 projection algorithm, and state-of-the-art algorithm called hybrid normalized limit square. This adaptive algorithm allows us to select one of the adaptive algorithm, and you can also change the parameters by double-click the small block here. Yeah, so you can change the setup for the adaptive filter. For pre-filter, we use two pre-filter here to pre-whiten the loudspeaker signal and the microphone signal before put it into the input of the adaptive filter. The output of the adaptive filter will be go to the AFC performance monitor here, and in this block we can compute the normalized misalignment and the added stable gain, and we can have a two scope here to show the performance of the normalized misalignment and added stable gain in real time. And we also compute the average misalignment and average added stable gain here. So our work focus on new on AFC platform. This is the end-to-end platform that allows us to flexible select the input signal, also flexible to select the adaptive algorithm, and we can also select use or not use the pre-filter here. And here is this input signal block, the pre-filtering block that I introduced before, and the adaptive filter block over there. And here's the AFC performance monitor block, where you can see the performance of the misalignment and added stable gain, two metrics that used to evaluate the performance of AFC methods. For the adaptive algorithm, we use the multiple adaptive algorithm from the common one like normalized limit square and the A5 projection algorithm. You can see the equation to update the filter coefficient as in equation number 1 and number 2 here. The difference is that in the API, we use the P-mode recent input vector. So why P of n here, it is a matrix that includes P recent vector of YP of n. By this way, we can use you can take advantage the spatial information and the resulting and you can get an improvement on the conversion rate and checking rate. Because the acoustic feedback part is quasi-sparse, so we can use some methods that based on the sparse of the feedback part is called the proportionate algorithm. For example, here we use the improved proportionate normalized limit square algorithm and improved proportionate alpha projection algorithm. And the update the coefficient of the adaptive filter as in equation number 3 and number 4 respectively. In those methods, the the step size mu here is a size corresponding to the strength of the current.
I'm sorry to interrupt, ma'am. The first 10 minutes of the presentations are over. Kindly proceed to the results of the presentation as soon as possible.
Okay, I will finish it in 3 minutes. Is it okay?
Yes, ma'am.
Okay. Okay, so I just go to the performance analysis here. Here you can see the performance of 5 algorithm that I that in this figure. So here is the misalignment and here is the at the stable gain. And here you can compare the conversion rate of all algorithm and you can see that the hybrid normalized limit square has the fastest conversion rate and the normalized limit square has the slowest conversion rate. And in this table, you can see the average misalignment and average at the stable gain for each algorithm. And you can see here the IP NLMS has the lowest misalignment and the highest at the stable gain. But the hybrid normalized limit square algorithm has the slowest has the fastest conversion rate. And here is the performance of the signal as the speak incoming signal. I mean the desired signal. And here is the signal that we received as the last speaker during the period of 29 seconds to 31 seconds. And you can see that the waveform look similar. And here is we conclude the paper. In this paper, we develop a modular real-time AFC research algorithm in MATLAB Simulink that allows the user can flexible select the adaptive algorithm as well as the input signal, and also can visualize the waveform of the signal as well as the output of the for each algorithm. In the future work, we will focus on develop another we integrate another algorithm like Kalman-based AFC method, and we can transform the code to the hardware. Thank you for your attention. If you have any question, I can respond for the question.
Lynn, which dataset have you used for performing this particular experiment?
Sorry, Vic, could you please repeat the question?
I just wanted to know the name of the data set on which you have performed your experiment.
Yeah, the name of the data set is I use for the speak. I use noises database yeah, the noises database. Yeah, I have it over there. Yeah, and I recorded it using the head and torso and sampling it at 16 kilohertz.
Yeah. Lynn, I would also like to ask you, what do you think are who could be the potential users of the proposed end-to-end adaptive feedback cancellation system, like the future application of what you have presented to us? Thank you for the impressive presentation. For the users of the system that you presented.
I think that you can, it's very useful for the student who study in the university or for the researcher. They can use it to verify the algorithm. For example, if the researcher or the student develop another adaptive feedback feedback cancellation, they can integrate it into the adaptive filter and then see the result in real time.
Yeah, thank you so much. Thank you.
Yeah, thank you.
You can stop sharing and we'll continue with the next one.
Okay, thank you very much.
Thank you for the presentation. I would now like to invite Sashika Harshani to present her paper titled Analyzing Privacy Policy Documents with LLMs.
Hello everyone. I'm Shashika from University of Turku. I'm a doctoral student, a first year doctoral student, and this research was conducted part of data privacy project that we have in our software engineering lab. Let me share my presentation. Hope everyone can see my presentation now. So the paper title is Analyzing Privacy Policy Documents with LLMs. The main target of this presentation, this research work is to
Shashika,
analyze.
your screen is not visible, I suppose, yet.
All right. How about now?
Yes.
Yeah.
Okay. As I mentioned earlier, the main focus of the research work is to analyze the performance of LLM, how good LLMs when it comes to analyzing privacy policy documents. When it comes to privacy policy documents, the main obstacles that we always see is they are extremely long with thousands of technical jargons and written in very dense language, and it is really difficult for an end user to read the entire document. And also it is very difficult to compare each other as well. So what we saw in the privacy policy documenting is they have to clearly specify what kind of data they collect, what kind of data they share with what type of third parties, and they have to use very simple language to explain what is the usage of data, the purpose of collecting the specific data categories. But when we study privacy policy documents manually, when we do the analysis, we identify that there's a huge gap between these purposes and what they actually present. This is the core research question that we ask: how reliable LLM when it comes to detecting gaps in privacy policies. Main focus went into identifying third parties when it comes to sharing data. So with that question in mind, we had another two areas that we focused, is which were false negatives, which is if an LLM identifies something that is not mentioned in the privacy policy, how destructful that could be. And the other one is false positives. I think I kind of missed up the those two earlier. So false positives, if they invent something that is not in the privacy policies, that gonna be a huge trust issues for the end users. And also when it comes to regulatory bodies, it's gonna be a huge problem as well. And on the other hand, false negatives, if they don't identify something that is mentioned in a vague language, or that is something that LLM can't identify directly, then that is also leading to a huge problem. So with those problems in mind, we have engineered a prompt to analyze the privacy policies. For this analysis, we only focused on Finnish media websites, because it is Finnish media and it is very limited. When it comes to Finland, we have a very limited market for media websites. And we carefully selected these most popular 10 media websites to analyze the privacy policy documents manually, because we only selected 10 because we did the manual analysis, and it kind of consumed a lot of time for us to draft the ground truth. But when it comes to LLM analysis, it was a bit difficult to build up the prompt, because it has to be very unified for the models that we selected. This the influence for model selection is for two reasons. One is obviously these models are very popular, and the other one is the resource availability of our lab. So we selected these four models out of the performances and the availability, and then we limited our privacy policies to 10 media websites because of the time consumption limit that we had. So the prompt engineering part was also very time consuming because of the unified approach that we followed for all the models and all the privacy policies. So when it comes to key findings, what we have identified is the model performance were fairly at 0.8 when it comes to recall. Most of these models could identify third parties, what they are engaging with. But when it comes to identifying whether it's a subsidiary or whether it's uh, a sub company of the same media web company, LLM had they fall short, because for example, even the same if it belongs to the same media company, they identify it as a third party, because the name, they only analyze the text, privacy policy text, using the text based language. So we have to feed it, or to uh, use prompt chaining in order to get a better results, which is not very unified, because for each media website, how they present and how the business function is vary. So that's why they have fall short when it comes to identifying the third parties clearly. But when it comes to GPT-4, they had the best F1 score, they when it comes to false positive and false negative, they performed the least number of ones, but still it is not very accurate because always it has to have the human eye to evaluate whether it actually uh, a, a, a third party that is explicitly mentioned in the privacy policy and what kind of data it is shared. Because in privacy policy documents, it's sort of like it comes with a category under law documents. So they use the intentional vague language or ambiguity is very natural when it comes to privacy policy documents. And LLMs is still not improved to identify those areas of ambiguity and vagueness. So that's why the scores, the precision range and F1 score is very low than we expected. And we tried multiple prompt engineering techniques to enhance this score, but I think this is the best we could get by the time that we run the experiment. And then, as I mentioned earlier, the hallucination part, it some of the models, since they have not tailored into one specific purpose, for example, Llama and Gemma, they are very generic and they try to hallucinate. They try to come up with their own, like they have their creativity of the LLMs and they invent entries which is not in the privacy policy document. So that is the hallucination rate, the false positive was 5 to 8 times higher than the miss rate as we calculated. So the conclusion is models were far more likely to invent an entity than to overlook a real one. So hallucination rate was incredibly high. Even with GPT-4, it is the same. The behavior was the same. And when it comes to efficiency and accuracy, so Llama, Gemma, and Gemma, when we do the experiments, Llama performs very quickly. It was really efficient, but the accuracy was very low. But then we tried, then we had this assumption that it will take time to get the better result. But since we've used GPT-4, it took less than Llama, but gave us better results. So then we realized that efficiency was accuracy. We couldn't come up with a pattern or a trade-off in between them because we use this technique to send same size of chunks from the privacy policy document. So the size was regardless, as in it is not a barrier or it wasn't a factor to affect the performance. But when it comes to the efficiency, GPT-4 performed better than Llama when it comes to time, and it still gave us a better result. So in that instance, we realized that we couldn't make a pattern or a trade-off in between the efficiency and accuracy. And for conclusion, we realized that LLMs, even though with all these fallbacks, it is a good technology to utilize, but still a human overlook is required. When it comes to things like vagueness, ambiguity, human overlook is still required to double confirm or to get the clarity of what actually these privacy policies say. But still we could use LLM to rate, as in to give to indicate a scale of low, medium, high sort of clarity for an end user, because we designed this entire process with the intention of having it in the web browser as a web browser extension. So this is a good way to have some sort of indication of what kind of privacy policy this is for an end user to look for. If they want to analyze further, then they have some sort of a warning, or there's some sort of requirement. This could create some sort of requirement in that way. But still, LLM alone can't analyze a privacy policy, how good a privacy policy define third parties and data sharing well. Like LLMs still can't do it alone. And as for future work, there are four areas that needs major improvements. For example, prompt engineering techniques, and also since as I mentioned earlier, we only focus on Finnish media websites, which is a very limited when it comes to our geolocation and what we have here. A larger data sets could give us more clarity and more statistics for LLM's performance. And also the latest models, they could definitely perform better now. This research was carried out last year during the summer, and definitely this is an area that we could improve. And having human, as in human overlook in the process is very much essential still for LLM's performance. So those are the conclusions that we made, and areas that we have identified for future improvement. Yeah, as I already mentioned, we are close but not yet ready to replace human oversight with LLMs, especially when it comes to legal documents like privacy policy analysis. These are the same things that I have mentioned. And if you have any other questions, you can shoot them now.
Yes, Shishika, very interesting presentation. Thank you so much. I had more questions, but you clarified everything regarding performance, for instance. But I still wonder, do you think that the regular regulatory frameworks like GDPR could benefit from these semi-automated tools, this approach that you presented to us? Do you think they can benefit from this?
Yeah, it is very much possible. Because I remember we had this conversation as well. But since this was initially designed for a web browser extension, our initial thought process, as in research idea, was to develop it for end users to get
To be informed.
yeah, like ease their use of websites, so they could have some sort of a urgency or a warning,
Yeah.
or to create that requirement for them to pay more attention into what they are dealing with.
Right.
This was part of another data privacy related project that we've been working on, and this is just one small part of that. So that's why maybe our focus was more tailored into the end user than regulatory bodies.
Thank you so much. Thank you.
Shashika, I just wanted to add if we think of adding explainable AI module in this, will it help LLM to provide some trustworthiness on the output that you are generating?
That could help. It's just, I think these legal document, the ambiguity and the vagueness of the legal document was the barrier. I think because, for example, we have these huge media websites in Finland. They have very advanced privacy policy documents. Like they have documented everything. It's just that in a tricky way, if I use the term correctly. So still I think it's not 100% possible to replace LLMs without human oversight because of this legality of these documents. Was that, as in, are you looking for that area or something else with explainable AI?
Okay, thank you.
We will now welcome our second presenter. We invite Yuvraj Singh Patil to present his paper titled Efficacy of Functional Electrical Simulations versus Conventional Chest Physiotherapy on Maximal Expiratory Pressure, that is MEP, Maximal Rate of Pressure Development, that is MRPD, and the Quality of Life Skill, that is QOLS, in CABG subjects, a pilot study.
Greetings, everyone. Am I audible?
Yes, you are audible.
Okay, thank you for the feedback. So, I'm Yuvraj Singh Patel, as ma'am introduced me. So, I'll get on with the presentation. I'll be sharing my screen shortly. Just give me a second. Uh, can everyone see my screen?
Yes, we can see your screen.
Thank you again for the feedback, ma'am. And so I'll get on with it. Like the title tells you most of it, the title itself is in Picot form. So we were trying to test the efficacy of functional electrical stimulation of particularly the abdominal muscles in subjects who have underwent CABG, elective coronary artery bypass surgery, which is a very common surgery that is being faced by patients over here. And this surgery is commonly associated with the post-op pulmonary complications such as ventilator-acquired pneumonia or acute respiratory distress syndrome or pain inhibitions of primary muscles of expiration and inspiration. So where there have been many sort of physiotherapeutic interventions that have throughout the years have been they have been proven to be efficient in order to improve the efficacy, in order to maintain the function of the respiratory system, that is to maintain the proper oxygenation and all. So studies have shown that CABG surgery is very commonly associated with reduced expiratory muscle strength, impaired cuff efficacy, and temporary decline in post-operative functional capacity. This respiratory muscle impairment may increase the risk of post-op pulmonary complications. Previous studies in neurological populations, such as spinal cord injury or traumatic brain injury, interventions such as functional electrical stimulations of the abdominal muscles have proven to be very much helpful in maintaining uh, the you can say the ability of the patient to maintain their airways clear. Okay, so in order to maintain clear airways, it is very important that your forced capacities are good, mainly your forced expiratory capacities. So the functional electrical stimulation has shown to enhance the expiratory muscle recruitment and improves cuff efficacy and overall lung capacity. Because of course, if your capacity to forcefully expire increases, your lung capacity will of course improve. These findings suggest potential applicability in post-operative cardiac patients also. That's why we considered as post-operative pulmonary complications and poor airway clearance is a common problem after surgeries like coronary artery bypass surgery. So we thought this might be helpful in order to maintain the airway clearance and to prevent the post-pulmonary complications such as ventilator-acquired pneumonia or acute respiratory distress syndrome, or many more like the clinicians face all over the world. So the objective of our study was to evaluate whether adding functional electrical stimulation to conventional chest physiotherapy. Conventional chest physiotherapy is nothing but exercises like you can say incentive spirometry, diaphragmatic breathing, thoracic expansion exercises. And if we think about particularly expiratory exercises, so you can think about splinted coughing, splinted huffing, and there are techniques like active cycle breathing techniques, and we also have segmental breathing techniques. Then there are some techniques such as autogenic drainage. But these techniques like autogenic drainage and active cycle breathing techniques, these techniques are very much dependent on whether the patient is able to understand the instructions, whether the therapist is able to convey the instructions. So there is very much room for communication gap. So in order to see whether that gap can be fulfilled by the functional electrical stimulation, we thought of combining this with the conventional chest physiotherapy, like I just briefly mentioned, the techniques which I just briefly mentioned. These are manual techniques which do not involve any type of electrical stimulation or anything. Conventional physiotherapy does not. And now talking about the, as you can see on the screen, talking about the maximal expiratory pressure and maximal rate of pressure development. So these both outcome measures are very reliable and valid outcome measures from which we can estimate the ability of the patient or the functional capacity of the patient in order to assess whether they are able to maintain proper airway clearance or not. And third of all, we have SF36 quality of life score. So this is a subjective outcome measure that we have kept in order to have both sort of data regarding the pilot study. And this is nothing but a simple questionnaire, and these are some daily activities of daily life dependent and feeling based questions that the patient answers, and we score according to that. So now study design. The study design was a randomized controlled pilot study where the control group was, like I told you, conventional physiotherapy. The duration was 2 weeks. 20 participants per group were chosen. Blinded outcome assessment. Significance level alpha was 0.05. Now the intervention structure. Group 1. Group 1 received conventional post-operative physiotherapy. Again, I would briefly mention the techniques used in that: segmental breathing, diaphragmatic breathing, splinted huffing and coughing, active cycle breathing techniques, and expiratory muscle strengthening and incentive spirometry. Then the group 2, it received all the above mentioned techniques. Alongside that, they received abdominal functional electrical stimulation for 20 minutes per session, 6 days a week for 2 weeks. And in these images, you can see, sorry, I forgot to. Okay. In these images, as you can see, this is the electrode placement, and this is a image of a patient. You cannot see the electrodes in the photo because after placing the electrodes, we use a chest binder to protect the sutures of the patient, and for further protection, we also provide a pillow for the patient to grab, so that while uh, coughing out or expirating or try to clear the airways, the sutures don't are not subjected to so much forces. So this is it. Next, you can see the baseline characteristics. The the mean and standard deviations are on the screen: 48 plus minus 9.83, 49 plus minus 7.97. Basically, the maximal expiratory pressure and maximal rate of pressure development was comparable at baseline, and the ages were also comparable at the baseline of both the groups. So the MEP result, maximum expiratory pressure results. I am displaying on the screen is displaying results that were observed on day 6 and day 14. On day 6, the group which received conventional physiotherapy showed 58.98 mm of Hg pressure, maximal expiratory pressure, and physiotherapy FEAC showed 56.58. And this on day 14, 68.06 was the score of physiotherapy, conventional physiotherapy group, and conventional physiotherapy plus functional electrical stimulation showed 7.2. So, as you can observe, the difference is larger after 6 days of the operation, and in the 14 days, the difference is not that much bigger or significant. It is very much comparable to each other. Similarly, when you look at the maximal rate of pressure development, so now the maximum expiratory pressure is explanatory, like it's the maximal expiratory pressure a person can develop in order to clear their airways. Now, the maximum rate of pressure development is the maximum rate. It is nothing but the amount of time taken to reach the maximal expiration. So in that we can see on day 6, again, the difference between the physiotherapy and the physiotherapy plus FES group is larger, and day 14, the difference is not that large. Sorry, on day 14 also the difference is large, but compared to day 6, the difference is not that large. So we can see both the outcome measure showed better differences on day 6 and on day 14. Both the groups had differences, but the differences were not as significant as on day 6. Now, SF36 results, again, I mentioned it is a quality of life scale and it is based on questionnaire and the score. So we can see the physiotherapy group and on day 6 and the physiotherapy plus FES group had a larger difference as compared to day 14. And these improvements were uh, parallel to the improvements that we have seen in the objective outcome measures also. So the limitations of our study was that the results need to be analyzed after conducting the study on a larger sample size, as our sample size was very small. These results cannot be universalized. Duration of the study can be longer in order to see whether the patient was able to maintain these gains even after he discontinued the sessions of functional electrical stimulation, or whether the patient was dependent on the stimulation in order to maintain those gains. Now, the only outcome assessment was blinded because of the nature of the intervention, therefore leaves room for development of bias. Because of the nature of the intervention, double blinding could not have been done. Clinical implications. Studies have suggested that enhancing expiratory muscle performance early, instead of day 14, if the patient is able to achieve his expiratory muscle performance on day 6, that may reduce the post-operative pulmonary complication risk, and adjunct abdominal functional electrical stimulation may represent as a promising argumentation to the physiotherapeutic strategy of post-op rehabilitation of a coronary artery bypass surgery patient. So this pilot study suggests that adjunct FES may provide additional improvements in expiratory strength and pressure development and quality of life following coronary artery bypass graft surgery. Larger randomized trials are required for the validation and the uh, assessment of the evidence that we have been gathering for the therapeutic intervention. So these are the references. Thank you for your time. I will stop sharing my screen now. I'm ready for questions if you have any.
Yes, please. I would like to ask you, at what post-operative day does the intervention begin?
Ma'am, the intervention begins on the post-operative day 2 itself. Post-operative day, we gave the patients time to settle down because the pain was too much uh, to introduce
Yeah.
intervention of such a nature. We are actually placing electrodes on the abdomen of a person who is carrying sutures on his mediastinum. So it is a very tricky thing. So on
Yeah.
day 2, we were
Yeah.
intervening.
Thank you.
Yes, ma'am.
Yuvraj, will there be any criteria for selecting the patients to whom we can apply this therapy or method?
Yes, ma'am. Any sort of abdominal injury or post-abdominal surgery in which the muscles or the anatomical structures of the abdomen have been uh, have been compromised in any sort of way, we cannot give this, or any sort of implants or something like that in the abdomen if there is present previously. And since it is the intervention is electrical in nature, we have to take care of those precautions also, ma'am.
In your pilot batch, what was the size of the sample or the patients on whom we have performed this?
Ma'am, the size was 20.
20 people or 20
Yes, ma'am.
patients you have performed this?
Yes, ma'am.
Okay. So was it in, means have you signed any MOU with the hospitals and all where you could perform this experiment?
Yes, ma'am. Actually, ma'am, it is part of a larger randomized control trial that we were planning. So it underwent through complete institutional ethical committee and all.
Okay, thank you, Yuvraj.
Yes, ma'am.
We would now like to invite our next presenter.
I'll stop sharing my screen.
We invite Rajini K to present her paper titled IoT-based smart ration shop management system for transparent and accurate public distribution.
Good evening to all. Is it audible to all?
Yes, ma'am.
Yes, ma'am.
Thank you, ma'am. Can you view my presentation?
Not yet. Yeah.
We
We
can
can
see
see
your
your screen.
Yes, ma'am.
One second, ma'am. Now is it visible, ma'am?
Not yet at my end. Now, yeah, now I can see it.
Ma'am, any issues sharing the screen?
Yeah, I am selecting the option for entire screen, but it is not visible at your end. That's why I'm trying, ma'am. One second, ma'am.
Mm. Just a second before I was able to see the presentation.
Ma'am, is it possible to view my screen?
Yes, ma'am, it is visible. You can start presentation. Just unmute yourself and start.
Okay, ma'am. Can you hear my voice?
Yeah.
Yes, ma'am.
Okay, ma'am. So myself, Rajini, I'm an assistant professor of Amrita Vidya Vishwabidam, India. So my topic is IoT-based smart ration shop management system for transparent and accurate public distribution. So what are all the contents I am going to cover? The introduction and what are all the existing problems available in this system and what is the proposed architecture and what are all the methodologies involved in that one, and then resultant discussion. So first we need to what is meant by ration shop and then what is the need for that system to ensure the basic food and household essentials are available to all the citizens in that city, in that country, especially the weak section, economically weak sections peoples. And also to ensure the food security for poor families and then reduce the hunger, and government will announcing many type of welfare, so how it will be reaching to the citizens to ensure those things. This I am developing a system. So actually what drawback of the existing system means, they are having a manual waiting, everything is done by a manual, so it will make some manual errors and corruptions.
Ma'am, your
So
slides are not actually changing. Are you changing your slides?
yes, ma'am.
No, we are seeing just the content slide.
Now it's moved to the introduction, it's not visible to you.
No. Now it's visible.
It will take some time, I think. Now it
Ma'am,
is in
it's visible.
introduction.
Yes. Yes, yes.
Okay, ma'am. So in the introductions, that is why we are need of the ration shop system to ensure the basic food and household essentials are available to all the citizens. For that only, the ration shop system was introduced. Actually, what are all the drawbacks or existing in that system is. So there are many of the manual errors and then corruptions that was happen in that one. To avoid that one, just I will convert those system into automatic using the IoT concept. And then the next one is here, problems will be available in the existing in the public distribution system. So some of the illegal activities occurs in the government ration distributions. So what is the issue means, for actually for all the peoples, they are having a smart card. In that smart card, where they are allocating a particular I mean amount of the items for all each category of the people. So but the manual weighting was happened. So what will happen means automatically they will reduce the weight. So all the things will not properly reaching the persons. That is a major drawback. To avoid that one, and then there is a no proper maintain, I mean transparency, and then accountability is also not available. To avoid to those two things, I developed a own system, that is by using a IoT. So this will be the limitations of the existing system. So the ration distribution system is most of the part is manual, and some of the part is only in automated. And then manual weighting may lead to inaccurate quantity distribution. And another one of the drawback is, so it is very difficult to authorities to track the distribution details, because they are not maintained in a particular database. So it is difficult to track the distributions where the errors was occur like that one. So who is misusing, that will be very difficult to that one. These are all the drawbacks of the existing system. And then proposed system. So what I did here to change that one is, so I introduced one of the, that is, yeah, smart ration shop management system is an automated and secure public distribution system, is designed to ensure the transparent and accurate distribution of essential commodities such as rice, wheat, and sugar, all eligible beneficiaries. So, and then here I use the technology IoT, and it will convert the traditional ration distribution into smart systems. So the alternate goal of that system is, and this system ensures the efficient and transparent distributions, and also it will maintain accuracy, also accurate measurement also. So what is the main objective of this system is, first one is here to maintain accurate weight measurement. Second one is we used a real-time data storage. So all the data are available in a database. So whenever the authorities need, they can verify it and enhance the transparency, and operations are very simple, and then it will also take less time than manual. So what are all the technologies used for to developing the system is RFID, and then ESP32 is used for the main controller, and then load cell for weighting the each items, and then IoT enables the real-time monitoring of distribution systems. So this will be my proposed architecture. In that one, my central part is Arduino UNO, that is a central controller. So it reads all the sensors values and process it, and then finally it will be displayed on the LCD, whatever the things happen within that one. And then I am having one RFID is a it's mainly used for a unique identification of each person. So already each person will have some set of categories of items with some weight. So when we are reading that ID, unique ID, automatically it will shows that particular person will have some rice is equal to 2 kg allocated weight, already government allocated weight for that one. So that will be displayed on that one. And load cell here used for weighting. So it will weigh so, and it will convert that force into electrical signal, and automatically that weight will be displayed finally on your LCD. And then all these operations are stored in a database. Here I used a Firebase database for storing all the informations. So this will be overall architecture of the system. And methodologies used for this one, first my phase is a login. Module 1 is my login phase. So first what will happen means the user or person will authenticated by using a RFID. After authentications, the allocated items for the particular person will be displayed on the LCD screen. So that details are displayed in the LCD screen. Then after then, when we are putting each and every item on the load cell, so that will match with already allocated weight. If both will be equal, then only the green signal will be enabled. After that, checking the green signal only, the person will make the fingerprint authentications. That is a user will make the fingerprint authentication. Say finally they will get all the weights are correctly like that one, to ensure all the weights are correctly done like that one. So in this data storage system, so whatever the measurements happens, everything is stored in a database. Finally the authorities can be this one. This will be a third module. And finally, finally the user can make a biometric authentication, so they will receive all the items with the correct measurement. So and also here with I added some screenshots about this one. So first, when we are reading that by using a RFID, then automatically the person's allocated weights will be displayed on your screen. So for example, sugar is equal to 2 kg, and then wheat is equal to 3 kg, and rice is equal to 1 kg, like that one. It will be displayed on the LCD. After then second set, so the person they can do the weight on the load cells. So if it is matches with the existing displayed weight, then only the green signal will be enabled, then only it will move to the next item. So after then, similarly, all the allocated items will be measured. Finally, they will do the fingerprint authentications after receiving all the items. So these all the transactions will be maintained in a database. So easily, the public authorities we can check they all the peoples are received the correct measurement with the correct item, like that one. So the final conclusion of this project is here: the smart ration shop management system using IoT provides an effective solution for major problems already existing in the public distribution system. And for that one, we are using small devices, RFID load cells, and then ESP32 reduces the human errors. And also these are all less cost also. The system also ensures the accurate and fair distributions of essential commodities to beneficiaries. And then also all the things are monitors in real time. And then it is based on a IoT concept. And this will be done till now. So what is the feature enhancement what I added to that one? So till now, whatever the things I will kept on the load cell, that weight will be measured. So it will not check what item actually I kept that for that one. So instead of rice, I can kept wheat or any other thing that is also measured 2 kg. The weight only checked. So just I will convert that into by using image processing what items also available on the load cell. So that is also we can verify and then make a little bit better than the existing system. And everything is the online payment is also added, I think added to this one, so for better of existing one. So these are all the some references of that one. That's it.
Thank you very much.
Emma?
I would like to
Yes, ma'am.
ask you a question, please. So,
Yes.
when you transmit the data to the cloud, do you encrypt it? The first one, and what will happen if there is an internet failure during the transaction loaded to the cloud?
Yeah, actually, till now I used a Firebase database. So whatever the weights measured, the corresponding RFID is already available, right? Unique identification with the corresponding ID. What are all the items are listed? I didn't use any encryption here. So that items, that's all displayed. That will be having storage. So anytime authorities can verify whether it is a properly done or not. That's it. Firebase means it's a cloud-based database, so it is useful to store a large number of your data.
Okay, thank you.
Thank you. Sorry
Rajni,
for
have you
disturbing you.
Rajni,
Yes,
have you
ma'am.
done the analysis of the ration shops who will be implementing such system in the rural areas? where the power
Yes,
cut
ma'am.
is the
Yes, ma'am.
frequent problem that they are facing. So how the
Yes,
system
ma'am.
will work in that particular area?
Yeah, it is analyzed, ma'am. It started to implement. So, but not at all. That is image processing, not yet properly implemented. But and other things started to. It will be analyzed with some ration shops. It's working properly.
Okay, thank you.
Thank you, ma'am. Thank you, ma'am.
We would now like to invite our next presenter. We invite Patrick Macharia Joroge to present his paper titled Optimizing Ad Hoc on Demand Distance Vector Routing Protocol with Energy Aware Passive Clustering in MANET.
So good afternoon.
Good afternoon.
Oh, sorry. In Kenya here, it's afternoon. I hope maybe in US or also could be in the morning. Are you able to see my screen?
Yes, we are able to see your screen.
Okay. Thank you so much. So I'm Patrick Macharia Njoroge. I'll be walking you through. Let me do the. Be walking you through a paper entitled "Optimizing Ad Hoc on Demand Distance Vector Routing Protocol with Energy-Aware Passive Clustering in Mobile Ad Hoc Networks." So the authors are Patrick Macharia Njoroge, John Gishokindia, and Daniel Makupi. So this will be the presentation outline. I'll just deal with a bit of study background, the aim of the research, a review of just passive clustering, a bit of it, the design of the AODV extended, and then I present the results and discussion, conclusion and future work, and then I do the references. So the background of the study, we are saying mobile ad hoc networks basically refers to collection of mobile nodes, and these nodes have networking and wireless communication capabilities, and they don't have any centralized infrastructure. So they don't rely on any prior laid down infrastructure. And you're saying that networks have become popular compared to the traditional wireless networks, mainly due to their characteristics of such as they are easy to deploy, their topology is very dynamic, nodes can join and can leave at any point. They don't require any prior laid down infrastructure, they are self-configuring and they are self-organizing. And in mobile ad hoc network, we have a node serving as a host as well as a router. So mobile ad hoc networks have found their application in disaster management, battlefield communications, mainly in the military, in smart homes, in law enforcement, healthcare, smart cities, road safety, search and rescue operations. But Manet also, despite it becoming popular, experiences some challenges, which are limited bandwidth, because most of the nodes which are in Manet have low bandwidth. We also have the routing overheads, the packet loss. That dynamic topology creates a lot of link breakages. There are security threats. The nodes also have limited battery power and also memory constraint. Mobile ad hoc networks basically has three classes of routing protocols. We have the reactive protocols, which actually discover route on demand. For example, the ad hoc on demand distance vector protocol, the dynamic source routing, and the temporary ordered routing algorithm. We have also the proactive or table driven. This one, they discover a route and then they keep it on the table ready, so that in case there is data to transmit, the route is ready and the data can be transmitted using the route available. Hybrid protocol employs both reactive and proactive characteristics. And we are saying that routing is very important in mobile ad hoc networks because it allows the formation and establishment of the basic linkages and communication among the mobile nodes. When mobile ad hoc networks are doing their routing, they use what we call the flooding mechanism. And this mechanism actually introduces a lot of routing overheads during the route discovery. And as a result of this vast controller traffic, these actually affects the efficient usage of the limited network bandwidth, the processing power, the memory, and the battery power, and this affects performance. Out of all the protocols we have discussed, AODV, which is a reactive protocol, is the most commonly used protocol in MANET because it is able to minimize some of these route broadcasts and avoid looping in routing. However, it still has the challenge of flooding, and that's why this research is coming up to try and address it, but I'll address it as we go along. So for us to address that challenge of excess routing overheads during routing, the researchers aim to integrate the energy-aware passive clustering in AODV, routing discovery architecture, to enable reduce the redundant route request broadcast and stabilize the network topology. And these will actually enhance performance in MANET. So when you talk about passive clustering, AODV as a protocol uses what we call the flat hierarchy, that is hop by hop communication or sharing of data. But we want to change that and introduce a hierarchical clustering or hierarchical routing, whereby we introduce clustering in the route discovery process so that we are able to stabilize the topology and ensure that now nodes can be grouped together. With passive clustering, nodes are grouped together, but these clusters are only formed when there is data to transmit. So we don't have, passive clustering does not incur the cost of having to run protocols or control packets which have first to create the clusters and then transmit data. The clusters are created when there is data to transmit and they are created on the go. And as a result, this reduces a lot of the overheads that we can have in the network. With passive clustering, nodes assume specific states. They can either be a cluster head, a gateway, or an ordinary node, or it can be in the initial state. Coming to the design of what we proposed, we have figure 1 there, which is showing the route request in a conventional mobile ad hoc network. So like in that case, we have S node being the source. It will send a route request to A. A will broadcast that to all the neighbors. So it will broadcast to C and B. B will broadcast to all the neighbors. And that's what is creating what we are calling the excess control traffic in the network. And this actually consumes the limited bandwidth, affecting performance. So in our work, we are proposing to introduce this clustering, whereby we cluster the nodes so that a node which has data and declares itself as a cluster head, and any other node within its transmission range joins the cluster of that particular node. And when we introduce that, we'll have some nodes acting as a cluster head. They control both intra and inter-cluster communication. Others will be the gateway, to be a gateway between two clusters. Others will just be members, which are ordinary. And also we shall have the initial nodes, which are not part of any network. So within our design, we propose to modify the route request headers and the route reply headers. We introduced these 3 fields here: the address of the first cluster head, the CHID1, address of the second cluster head, CHID2, the cluster identity, and the energy of node. Also, for the route reply header was also modified to introduce the cluster identity and as well as the energy of the node and the state. Within the routing table also, we introduced these fields: the state of the node, the cluster ID, and the energy of the node. So let me see, let's go to the simulation results and a bit of discussion. So the extended AODV protocol was evaluated using NS2, version 2.35. This was chosen because most of the studies around MANET were using this, and also NS2 is very strong when it comes to providing features which are very unique to MANET or mobile ad hoc networks. So we compared the results of extended AODV with conventional AODV, ad hoc on-demand multipath, distance vector, and energy-aware AODV protocol as benchmark variants. We used 3 network performance metrics, that is the throughput, the routing overhead, and end-to-end delay for our evaluation. So the table there, table 1, shows some of the simulation parameters that we used. And we could go now to the results of the routing overhead. As you can see, this I don't know whether this is purple color, could help me. When it comes to routing overhead, this being the extended protocol which is proposed, compared to the energy aware protocol, the conventional AODV, the AODV MDV, XODV performed very, very well. Actually, in terms of reduction of the routing overhead, when all these other protocols were hitting a million control packets, the extended AODV protocol was it went to a maximum of around 17,000 and I think 800 control protocol. So there was a reduction in routing overhead between between 97%, 98%, as node density varied from 10 to actually 150. So, and because of that, we are saying the XDVU protocol was considered to be scalable and had a very high routing efficiency. And this was attributed to the incorporation of the energy-aware passive clustering within its routing discovery or route discovery protocol. And this also ensured that the network had, the longevity was actually, the network lifetime was actually elongated. In terms of end-to-end delay, actually that the proposed protocol, as shown in the above figure, reduced the delay in the network when compared to the benchmark variance. The reduction was between 71% and 78%, while the proposed protocol had a delay of less than 1 second, all the way up to the node of 150. The others, benchmark variance, went up to 4 seconds. And this performance was attributed, or this performance was attributed to the introduction of the passive clustering, which was energy aware within that. It was able to reduce the routing overhead, destabilize the network, and so the network was able to perform very, very well compared to the benchmark. In terms of throughput, we see that the XODV, the proposed, actually had a steady rise in throughput of between 77% and 125% when compared to AODV, AOMDV, and EODV. And this was actually attributed to the reduction in unnecessary broadcasts and stabilized network topology, leading to higher throughput, mainly because of incorporation of the energy-aware passive clustering within AODV itself. But to realize that for nodes up to around 40, the proposed protocol didn't perform very well, while these others performed very well, because at low nodes, AODV, AOMDV, EAODV have very low routing overhead, and so routes are able to be established, and communication takes place in real time and very, very fast. But when they hit 40 nodes plus, that starts dipping now, because now we'll have an increase in routing overhead, and so the performance goes down. But for our proposed protocol, that now was on the rise all the way up to around 89 packets per second. So we from our study, we are saying that the paper presented presents the extended AODV routing protocol, and this was determined to have a high routing efficiency, and therefore so it was scalable with increase in node density. The scalability and routing efficiency is expected to be upheld with node density above 150. And then the proposed protocol had faster delivery times and better real-time performance, and it reduced routing overheads by between 97% to 98% in mobile ad hoc networks. The end-to-end delay was averagely reduced by 71% to 78%, and throughput was increased by 77% and 125%. So that makes us to infer that the proposed protocol is suitable for deployment in real-world mobile ad hoc networks for enhanced performance. And future work proposes to explore the standardization of the proposed protocol and eventual real-world implementation of the extended AODV algorithms and architectures in mobile ad hoc network. So these are some of the references that we used. Thank you so much for listening to me.
Thank you, Patrick. Thank you. May I ask you once again, please, to summarize and tell us what are the main benefits of the proposed approach, please?
Thank you. The proposed approach has basically 3 main benefits. One, it is reducing the routing overhead within the mobile ad hoc network, and by so doing, it is improving on the routing efficiency of the protocol. As we saw, it had a very high routing efficiency. And that means that within that network, if this is adopted, transmission, communication will take place very, very fast. In terms of the delay, it reduced the delay within the network, and that means that the network which adopts this has faster delivery times. In terms of throughput, the experience increased throughput. So if it is adopted in the network, then throughput will actually go a long way increasing. Thank you.
Thank you very much.
Patrick, does the cluster size or the cluster formation process impacts the result?
Sorry?
Does the cluster formation process or the cluster size impacts the result?
The cluster formation, it only affects up to around 40 nodes. That's why we have up to 40 nodes, yet it affects. But beyond a network with more than 40 nodes, the scalability increases and even the performance. So the benefit for that would outweigh the lagging that might bring within the network.
Okay, thank you, Patrick.
Okay, thank you.
We would now like to welcome our next presenter.
I hope you can see my screen. Oh, sorry.
Actually, we have to introduce you first. Just a minute. Sorry for interrupting. We would now like to invite Sai Gautam Mandapati to present his paper titled Redefining Cyber Insurance Challenges, Gaps, and a Framework for Empirical Research.
Thanks, Vidhi. Let me share my screen. I hope you guys can see my screen.
Yes, we can see your screen.
All right, thank you. So my name is Dr. Sai Gautam Mandapati, and I'm from TNK2 Proprietary Limited. So we are located in Melbourne, Australia. So today I will present our work examining the structural gaps in current cyber insurance practice and proposing an empirically grounded research framework to improve risk modeling. So while the cyber insurance market is expanding rapidly, its underlying modeling assumptions remain underdeveloped, and in some cases, they are misaligned with the cyber risk realities. So our research seeks to identify these structural limitations and propose a more rigorous path forward. So this is what like our research is all about. So cyber incidents, as they create a systemic, like operational, financial, and like regulatory consequences across different types of industries. So the global insurance market, according to our research, is around 20 billion USD. So, however, adoption is uneven and across different sectors, and premium volatility has increased significantly. So particularly following the surge in the ransomware incidents nowadays. So yeah, that's a big problem. So now, because of this, there is a creation of paradox. So the market is growing, yet instability and mistrust, they always remain. So growth alone doesn't imply structural maturity. So if modeling assumptions are weak, so expansion may amplify risk rather than mitigating it. So like we have identified the core issue here. So cyber insurance promises risk transfer. However, several structural concerns still persist. So first one is the pricing transparency, and it is limited, and historical actuarial data sets are weak, and security posture is inconsistently weighted in underwriting decisions, and regulatory alignment remains fragmented. So these constraints reduce the pricing fairness and discourage well-secured organizations from purchasing coverages, and increase insurer exposure to underprepared clients. So this leads to the research question. So what structural limitations undermine cyber insurance modeling, and how can they be addressed? So The first, before we go into looking into the challenges, so we basically, found that, okay, these are the three dominant strands in this area. So the first one is the actuarial modeling. So actuarial modeling research focuses on frequency and severity estimations. And second, policy and market research examines transparency, systemic risk, and regulatory design. And the third one is the human and socio-technical research, which explores the behavioral contribution to cyber incidents. So often we miss these, the important human, the socio-technical risk. So this gap is limited, and across these domains. So actuarial models often exclude behavioral dimensions. So, and the policy research rarely connects to quantitative modeling. So human factors is completely avoided, in certain frameworks. So our contribution aims to integrate these strands into coherent research structure. So the first sort of challenge when we came across while we were doing our research is, so current pricing models so frequently rely on revenue and infrastructure proxies. So however, cyber incidents primarily target the data assets. So the data value varies by sensitivity, sectors, regulatory exposures, and temporal characteristics as well. So based on the industry that the cyber incidents are going to happen, so the data that could be coming out could be like a possible victim. So without structured data asset valuation, so pricing mechanisms may systematically misestimate the exposure. So we argue that cyber insurance must reframe the insurable asset around the structured data set valuation rather than infrastructure proxies alone. So here the first challenge is about data assets. And next is the industry and security weighting. So base rate pricing structure dominate many underwriting approaches, and sector multipliers are often like coarse, and security posture adjustments are frequently opaque and financially marginal. So because of this, SMEs can be the major victim, and that security posture explains less than half of the observed premium variation. So this weak incentive alignment undermines the cybersecurity investment and reduces the actuarial precision. So the third challenge we identified as the dynamic and cascading loss. So cyber incidents exhibit epidemic propagation patterns. So loss unfolds in stages. So it's not just it happens right away. So they go through stages, and so immediate operational disruption, medium-term reputational damage, and cascading supply chain effects. So these could be the problems. And human behavior so further amplifies these particular risks, because any sort of internal attacks happening on the network, so generally they start from the mostly could be from the internal attacks. And here, the often tendency is the ignoring factor is the human behavior. So, most underwriting models underestimate these cascading and socio-technical dynamics. So, based on this, so the proposed research framework is designed. So, it's 4 construct frameworks. So, first, it's as I mentioned, the challenges. So the framework addresses those challenges. So the first is structured data asset valuation. Second is granular industry and security posture assessment. And the third is dynamic incident impact modeling. And fourth is the regulatory alignment supported by structured data sharing. So this framework integrates actuarial modeling with socio-technical and regulatory dimensions. So it is designed for empirical operationalization, not remaining purely conceptual. So the first, when it comes to these particular cyber insurance framework that we developed. So we propose to implement this as a minimum viable product as a support tool. And so pilot studies will be conducted with SMEs across different sectors. So we are in the process of doing that right now. So we don't have any results, but surely we'll be getting results from the SMEs. And so this approach responds directly to the need for measurable validation in cyber insurance research. So the research contributes in 4 ways. So it reframes insurable asset around data and integrates the security posture into actuarial weighting and incorporates propagation modeling, and it emphasizes structured data sharing to stabilize markets. So the outcome would be the improved pricing fairness and actuarial precision and systemic resilience, which is what is most of the cyber insurance frameworks that currently in the market lack. So improving cyber insurance requires moving beyond revenue proxies and static models towards data-centric, behavior-aware, and empirically validated frameworks. Thank you, and yeah, I welcome your questions.
Yeah, you can, but baadaye huwa zina insist.
Fine,
But you can
nice
create it.
presentation. Only all the
Thanks.
challenges that you have considered are critical. I give you my best wishes that you come up with a good outcome
Oh
and
yes,
with a better
thank
product.
you.
Yeah.
Thanks, thank you.
Patrick,
Yeah, you
would you
can
please
create. Kuna
mute
wakati inapita
yourself?
link. Kuna wakati
Patrick, would you yeah, thank you. Okay, now I can also ask you
Yeah.
something.
Yes, Doctor.
What do you think are the biggest obstacles to implement the proposed framework in practice?
So nice question, Pepper. I feel like it's mostly around regulatory aspects, because most of the cyber insurance frameworks are, very clear in in terms of their regulatory, the compliance, especially.
Mm-hmm.
So the idea is to at least sort of start, to match our framework to certain industry accepted regulations, and we are working towards it. So yeah, moving forward, we will try to at least make this framework suitable to the current regulations, and at the same time get the accurate sort of the insurance policies for the individuals or the SMEs. Yes.
Thank you very much.
No, thank you.
I sincerely thank our authors for their excellent presentations and contribution to this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICICT 2026.
Thank you.
We also thank our session chair members. I also thank our session members for chairing the session. A token of appreciation to the chair on behalf of Team ICICT 2026 and Global Knowledge Research Foundation and partners. Is my screen visible?
Yes, Vidhi.
Yes. These are our tokens for the session shares to Professor Peppa Petrova and to Professor Rachna Savle. We kindly request you to turn on your cameras for a picture. And to all participants of the meeting, I hope you have a great day ahead. Take care.
Thank you very
Thank you.
much for leading the session. Bye bye, everyone.
Thank you.
Bye.
Thank you.
Thank you. Goodbye.